Right, so I've got the, I'm just trying to understand completely the details on how this rather complex solenoid works. The manual says that there are two coils, once again, and I compared it to the what the manual says on another car, 12-volt car, also from the 60s, and it doesn't mention having a second coil, and it doesn't show a second coil on the diagrams either. But the diagrams they have, they're not the most, complete diagrams in the world. Now, before we go any further, I'd just like to show you an interesting phenomena here. I've got a battery charger. There it is at 6 volt. Light is on. I just put one end of the charger to the casing, to the housing here of the solenoid, and the other end goes to the end of a multimeter, right? So basically, the when I connect this, I'm using this end here as a probe, and wherever there is electricity, it's going to complete the circuit. Just imagine electricity is just a flow of, just like water, right? So let's see, there's water coming out here, right, from the charger. It's going here, right, going all around into the multimeter. It's going nowhere, so there's no flow, right? There's only going to be a flow when this end is connected to that end. So if I connect both ends directly, like that, there's not going to be a spark because it's just telling me what the voltage is. If I were to actually connect these two, then yes, there would be a spark. But there it is, you see, 6 point. Let me get the paint on here. Mind that there's paint. Paint doesn't conduct electricity really well. And rust, so that's nice and clean now. We're at 6.88 volts. Right now, the interesting thing is, watch what happens if I hold the end of the probe with my finger. Still have 0 volts there, but let's say I'm holding the probe and I touch my hand there. Watch what happens. Get a little bit of voltage in this case. About 4 volts. If I go even closer, let's say, I don't feel anything. It doesn't hurt at all. See there? What do we have? 4.7 something. Really close now. Right, so just mind that your arm, your skin does conduct electricity. Now the thing that's really bothering me here is that there's this piece of insulation here. And then you put this on top, right? This goes over like that. And you see I've put a piece of tape around where it was supposed to go connect here on the electromagnet. Right? And inside there's space you won't be able to see here, but I can see that it's literally not touching anything. And I was using my hand to hold it like that. And then I really need to get myself a stand. And then I was using the probe like this, holding it, and then I was getting some voltage. You're not getting, this doesn't have any voltage on it right now, you see. Because remember, it's not connected to anything right now. So right now we're at 0 volts where it was supposed to be. Come on, you fucking bitch. Now in the demonstration, it's not happening. I was actually getting like 4 point something volts there, which was really weird. And now because there's insulation here, that makes sense, right? We don't have any voltage going here because it's completely insulated. gotta make sure. But now that leads to another problem that's really bothering me. This contact point, where does it go to? It's basically connected to nothing. It's connected to here, you see there. It's basically connected to nothing. I mean, like, there's no voltage going to it. So like I said, you see everything's insulated here. So the electromagnet here is just completely insulated from anything and everything else. The way to turn it on is through these two terminals. But what about this contact point here? I know it goes to the to these two wires of the two coils that make these big electromagnets in the solenoid. But what about the other end? It's saying that it's going to here. There's no continuation. There's no flow. And this is what is really bothering me. This is really weird. Because this is completely insulated. And even if we did have electricity, I mean, it's just really weird. We must have electricity here, but this insulation plate says that we don't. Maybe we're not supposed to have that insulation plate there. It's supposed to be connected like this. Yeah, that would make sense. I think this insulation plate goes here like this, not underneath this, and that's the only way that it would make sense. Unfortunately, I have the manual here. Just turn this off. But the best way to really make sure that you have no electricity, I don't really trust those things. I mean, I use it, but, just to make sure, these things are electronic. They break, they show wrong results, they're really complicated. I don't really trust them. So the best way to test something electrical is through the spark test. You just quickly spark it, touch the other lead and see if you have a spark. That means you have electricity going through it. Just make sure that all these parts here, they're dry. Don't put oil, don't put anything on it. Gasoline or diesel will damage the wire insulation, so don't do that either. I just scrubbed it outside with a brush. You can't do that, that's not a problem, obviously. Just make sure it's nice and dry because oil does conduct electricity. All right, now for the second problem. That's really got me sort of, it's really weird. I'd really think that this went like this, but it doesn't make sense if it's like that. It's got to be like this. It's the only way that would make sense. I'm pretty sure I found it like that. But you see, if I put it that way, it's actually hitting the wire there, which is really weird. See, there's even this part of the this electromagnetic assembly here. It's hitting the wire there. You see there? And eventually it'll damage the insulation. It's a little bit damaged already. And if I put if I remove this insulation plate here, this will get even lower and it will really sink into that. So see, that adds an extra height so that it's not really touching. See that? If I remove that insulation plate, then now they're touching. Really fucking weird. Right, and you can't press all the way down without removing the wire. So that is really fucking weird. I mean, it's the insulation. You see, the insulation is actually what's touching there, so it's not a big deal, but I don't want to damage that, so this is really weird. Now, the other thing, so you go to the manual, and unfortunately, you know, although the manual is pretty good, all these cars still miss a lot of detail. So there's the solenoid there. And the first thing I'd like to show you guys is, see that here they have the numbering on the numbers that correspond to, you know, whatever parts. And if we start here on the top, there's no number for this terminal here. There's a number now because I put it there. See, number, why not no number here? So straight away I can tell that these guys, you know, they're a bit lousy. Okay, at least the guys that did this. The thing is, it's not one person. This is the problem, guys. This is the issue. It's not one person that does the entire car. It's usually one person or one company does the alternator, the other company does the starter, one company does the body of the car. So, you know, it's not one person that supervises everything. So there are parts where it's really good quality, and there are parts where it's just fucking lousy. Engineers and these people, they've got a reputation with me for being stupid assholes. Okay, so they didn't put a number there. So how did I figure out it was 15? Because they put a number here. But, you know, which position is this in? So if you look here, you know, are they looking, you know, like this, or is it the other way around? Like that, like this, or like that, right? So the way I figured it out is the other terminal, they put the number there, 7. So I came here, number 7, battery terminal. Okay. And then, well, this terminal has to be the same as either one of these. But they have different numbers on both. So I'm like, what the fuck? And then I came here, and you look here, and number 14 is battery terminal also. So either you have two battery terminals, or they're the same terminal. Well, there's only two terminals here, and one isn't the battery. Therefore, both of them are the same terminals. So you see, guys, these guys, they really fucked up here. Whoever did this, whoever made this diagram, I have a message for you. Fuck you, you fucking idiot. What the fuck were you thinking? So then I corrected that, and I actually put here 14 equals number 7. And I also wrote, why give them different numbers if they're the same part, fucking assholes? This really pisses me off, guys. Why? Why omit the number here? Fucking unbelievable. But anyways, moving on. You see on the top, they actually put both of them. You see number 5 and number 2. So, there you have it. So straight away, when I see that, guys, I can tell you that there's something weird here. You know, something's not right here. Either the diagrams, you know, you might not. I don't usually trust these diagrams. I mean, I trust them. I usually trust them. How can I say this? I usually trust them, but I much rather completely understand what's going on rather than following, you know, numbers that can be wrong, right? So I like to understand what I'm doing. And then, so if that wasn't sufficient, right, this fuck up here, then we go over to the diagram on the right here, and you'll see that the position that this is in is like this. I'm going to put it in the actual position here for you guys to see. Just turn off the battery charger. It's the position it's in. It's like this. Obviously, I've got everything removed, but let's see if you notice the difference. Got that? You see? The terminals, the actual terminals, the smaller terminals, they're actually pretty long. On the diagram here, they're short. Okay? See that? That's the head of the screw. And here it's a bolt that goes into it instead of a bolt sticking out with the nut at the end. So here's the reverse. Right, so obviously it's a little different. Perhaps some of the other models were like that, like this, I don't know. But that straight away, that tells me that there's something different here. And then when I'm reading the manual here, I'm just going to read what it says there. Part. Okay, when the relay armature closes, it says there, current then flows from the battery connections at the solenoid. Okay, straight away. Let's stop there. The battery connections at the solenoid. Okay, what the fuck is that, guys? You just gave me numbers here with specific names. And now you're just coming up with, battery connections. What the fucking hell is that? What in the fucking hell is that? God damn it. What the hell is that? Why don't you just give me the number, number 15, or, relay winding, number 6, solenoid plunger, number 11. What the hell is battery connections? So this is fucking unbelievable. So you see, I can always find some big fuck-ups, even back then. Okay, but moving on. So that's... then the relay points, okay, battery connections at the solenoid through the relay points and coils of the solenoid. Now here's the second problem. Current then flows from the battery connection at the solenoid through the relay points separate and coils of the solenoid. That makes sense. Or is it relay points and coils of the solenoid? So does the current flow through the relay and the coils, which are both in the solenoid, all of the one which are in the solenoid, or is it the relay points of that electromagnet and the coils of the actual, this part here? It's not a big deal, but that's a problem. The solenoid winding is made up of 2 coils. One coil is connected from the relay points. Okay, here's the second problem. One coil is connected from the relay points. Okay, which one of them? There's 2 coils. One is connected to one point, one is connected to the other. One coil isn't connected to both of the points. What the fuck is that? From the relay points to the starter side of the solenoid starter switch. That really killed me there. Starter side of the solenoid starter switch. Jesus Christ, man. Come on, guys. Starter side. Which one is the starter side? Why don't you just give me a fucking goddamn number? You just gave them numbers here. And now you're giving them weird names? Fuck. So then I had to go and look for it. So it says starter side. So let's stop there. Of the solenoid. Obviously, we're talking about the solenoid here. Where is it going to be? Starter side of the fuel tank, you motherfucking bitches? Anyways, so starter side. So then you go here. Well, which one is the starter connection? Starter connection is number 15. So probably the one that they're saying here, the starter side, the relay point on that side is number 2, right? And I just put number 15 there because that's the starter motor terminal, right? So one coil is connected from the relay points. We don't know which point. It says points, plural, so it doesn't specify which point. Fucking bitches. You can't know. There's no way. This is another problem. We have no way of knowing which one from what they have here. You actually have to open it up and study what's going on inside the relay and solenoid. But anyways, it says relay points to the starter side of the solenoid switch. So the starter side, it's obviously one terminal is connected to one of those little terminals. Let's translate this. The coil, one of the coils is connected to the relay, one of the relay points. Remember, a coil, it has 2 open ends, right? So here's a coil. There's gives lots of turns. Then out it comes on the other end. There's two ends. So one end is connected to the electromagnet, and the other end must be connected to one of those big terminals, right? And that's obvious because, like I said, you need a lot of current, a lot of electricity. Can't have both of them connected to those tiny little terminals there. So the other terminal is connected to number 15. Starter side. Look how much simpler I made it. They called it starter side of the solenoid starter switch. I just called it number 15. I mean, guys, why? Anyway, so they said the other coil is connected from the same side of the relay. Once again, that's just from the same side of the relay points. Why don't you just give which relay point it is? Is it number 1? Sorry, is it number 2? Or is it number 5? What's it going to be, you motherfucking assholes? Where were we? The other coil is connected from the same side to the points to ground. So it's connected to the someplace either on the frame of the car or any piece of steel that's connected to the frame of the car. Start off. Now, moving on from that. Let me actually show you guys. And the only place where these two wires are connected, once we move with them together, there you have it. Both coils. You see, one is pretty thick. One is really thick. The other one is thin. There's another thin wire right there, and it's connected to this metal part here. So this is the coil that's connected to ground. The thin coil is connected through this point here to ground, and the thick coil, it's connected from the same point here, but it's connected to this terminal here. Right, the big thick terminal. And once again, it only turns on once the plunger is depressed, so that the 2 points there, so that's connected to the battery like that. Right? So we've determined that part now. So moving on, then it goes on to say, when the relay points are first closed, 85 amps flows through both coils, which immediately pulls in the solenoid plunger and shift lever. Okay, so both coils are 85 amps. In the previous video I said that one of them is 85 amps. If we go on a little bit further down here, as the starter disc is closed, switch disc is closed, one coil of the solenoid is shorted out. Coil from battery lead post to starter side, which is number 15. I'm just going to cross that out and put number 15 in this place. Just watch me, guys. Cross it out. Where the fuck is it? Coil from battery lead post. You know why battery lead post? It's just battery post. Battery post 2. Starter side solenoid switch. Look, crossed it out fucking completely. It's number 15. Post to 15. There you go. Fucking assholes. The second coil remains in the circuit with sufficient current, 12.5 amps, to hold the pinion in engagement with the flywheel. Okay, so it's actually still holding the plunger there. So, which means one of them is 12.5. Both of them together is 85. So the other terminal must be 85 minus 12. The other coil, must be 85 minus 12.5. Okay, that's what it's. Because both of them together have to equal 85. That's how much they used. One of them is 12.5, so the other one is 85 minus 12.5, right? Let's see. Now, the other thing that I found important here, the things that I'm not reading are pretty obvious, but the thing that I also find interesting here is the solenoid circuit is also interrupted when the generator speed increases on starting of the engine due to voltage buildup, which opposes the flow of current from the push button. Okay, so remember that one of the terminals here, one of these terminals here, which on the diagram here, it's the one on the left. See, number 2 is ground terminal. And then if you go on to the larger diagram, I think it says here as well, the ground terminal is connected, remember, not directly to ground in this case. They're connected to the generator. So when the car is off, the generator is not producing electricity. So electricity is going to it. Which is from this point, this terminal here, to the generator. Now, once the car, starts, then the generator starts to produce electricity, and instead of electricity going to it, electricity starts going from it. So instead of electricity coming out of this point, electricity is then coming into this point from the generator. So it's just basically like imagine just getting a garden hose, 2 garden hoses, and pressing them together. The water is gonna oppose the flow of the other hose, right? The one hose is gonna oppose the flow of water from the other hose. So it says that causes the circuit here to turn off. But once again, it's still pretty vague which circuit. Is it the electromagnet? Is it which coil of the solenoid? It's pretty much vague. They don't give a lot of detail, unfortunately. And they did like to complicate things a little more here. Whoever wrote this did sort of complicate it. Now, moving on from that, the key point that I'd like to emphasize here is that it says when the relay points are first closed, and I'll actually, let me just demonstrate to you guys the relay points closing. There's one terminal, connect one terminal here, turn on the battery charger again. It is on. And will not stay like this. If I connect it to the body of this, just to prove to you guys that this is insulated. Remember, the other terminal is on, and I touch it here. See? Nothing happens to these terminals. There's no spark. So this is not connected to this, but it is connected to this sort of bracket here, right? So here's a spark test. It's a quick spark. See that? Doesn't damage it at all. Now, to show you guys how the electromagnet works, see that's open there? I'm going to connect one terminal here to one terminal. Sorry, one terminal to one terminal. Watch what happens now. It's going crazy like that because the connection here is not good. Hang on. Come on, you piece of shit. There, that's better now. See that? Obviously, you don't want to hold it here for too long because, it's not going to damage it. Only if you hold it for really long, perhaps, but... And it doesn't harm your fingers. You can put your fingers here, 12 volts, I think up to like 60 volts. You're pretty much safe. So, battery terminal, even if I put my hand across both of them, you see it doesn't hurt at all. If my hands were wet, then I'd sort of feel a little bit of a shock, but once again, sometimes it's not working because the end of the thread here, it's a little bit rusted, so the electricity doesn't flow as nicely there. Right, so there you have it. Okay, let's turn this off. So now that thing is, see, electricity goes in through here and here, but these points, what are they connected to? We know that one of them, this one here, is connected to both coils, but what is the other end connected to? Yes, connected through here, but this is insulated. Or at least I think it is. Doesn't really make sense at all if it's insulated. Alright, so moving on from that, it goes on to say, like I said, that both coils are supposed to be on. See, when the relay points are first closed, that's that click that I was hearing on the video, remember? Relay points close. Electricity then flows through them. If you don't yet know where it comes from or to. 85 amps flows through both coils. The previous video said that it would flow through one coil and then through the other one, but it's saying here that it's actually through both coils. So that makes sense since they're both connected here. So let me just, I think I'll remove this. Let me just remove these two bolts here quickly. No, I think you guys can see it pretty well. Now, the thin coil is obviously, it's hard to see, but the thin coil here, let me zoom in. The thin coil here, it actually, you look at it this way, it sort of seems that it's going here, but it's not, guys. Let me just turn this around so that you can see. See where it's going in? It's actually going in through here. See? Right there. And it comes out through here. So this coil is connected